Hi there, and you're very welcome to our third episode of the Science Lesson Support System, suitable for primary school from ages 6 to secondary and right through to long life learners. In our last episode we covered climate change and the environment and how these simple little resources can help make learning and teaching science easier for both the teacher and the student. Today we'll be covering solids, liquids and gases and look at how this support system adds connectivity to all areas of science and nature, allowing for a better integration of topics and differentiation for students. So let's get started and building our solids, liquids and gases display. All we need is a regular kitchen display tray, something like one of these, a hot glue gun, some molecules, and a bit of paper and a marker. The elements we're playing today with are carbon, which is black, hydrogen, which are the white ones, and oxygen, which are the red ones. But you can build this with whatever molecules or elements you want to. Simply Google a solid, liquid or gas that you're interested in and put the word molecule after it. Click images and click on the one that you see 90% of the time. Trust the majority. As mentioned, atoms love to make friends, and when they do, they form a molecule. Each colour atom represents a different element, found here on the periodic table of elements. So let's make a solid. A solid is when any element has a spare electron to connect and gets bigger and bigger and bigger until they either run out of friends or electrons or some force restricts its growth. Crystals and diamond are an amazing solid. Diamond is made of carbon forming a nice uniform lattice structure that we will cover later in episode 8. So simply connect as many black carbons as you like using any electron connectors you like. For this display, I find the long ones are the best. We explained in episode 1 that for primary, any electron connector is fine as an electron. It's more important to keep things simple and easy. And voila, we have a solid. Hot glue it down and label it and you're done. A small tip is to let the excess stringy glue dry first before you remove it. It's easier to remove when it's completely dry, otherwise you'll risk smudging it. The hot glue guns are the best in our opinion, as if you make a mistake, if you give it a good tuck, everything will rip back out and they'll peel back off of the molecule and there's no damage done, no marks or no abrasions. We usually recommend the small stud connectors for displays, but this solid in particular required the longer connectors to help it sit properly, but this is not a rule. The longer connectors are easier to use in a classroom environment and it helps the students to assemble and disassemble their molecules much easier and faster. Okay, now that we have our solid done, now let's make our liquid. There are many forms of molecular liquid you can Google, but we will go with simple water for now, which is built simply with one O for oxygen and two H's for hydrogen, so we call it H2O. When making H2O in class, we encourage you to ignore why some elements have different amounts of holes, but I'll touch on all this in episode 12. Just for this one occasion, when we're making our permanent display, we're as well to use the oxygens with the two holes only. The only time we deviate from this advice is just making this one permanent display. And same for the electrons. The longer ones are much easier to use in a class environment when we're putting atoms together and pulling them apart. So we'll be as well to use the short ones in our permanent displays that we're gluing down, as we won't really have a use for them anyway, as it will look much better. So as mentioned, water doesn't use its bonds in the same way as solids would in order to make, let's say, rocks. But they are team players. They can borrow them from their oxygen neighbours. These special secret bonds are called hydrogen bonds. Hydrogen bonds also explain surface tension, allowing a fly to walk on the surface of the water without falling in. But these secret bonds doesn't allow this molecule to form anything like a rock at traditional normal temperatures. So let's set these down in a way that remind us that hydrogen bonds do something important. And that's the reason on this occasion only that we'll be going with the oxygen with the 2 holes, simply just to remind you as the teacher that something is going on. Borrowing some video from the Astrum channel linked below, in liquid water the bonds between hydrogen atoms are very, very weak, constantly breaking and rebonding as the molecules move about. We can display this by gluing our molecules down in lots of different ways and patterns. Sometimes they're bonded, sometimes they're not. But when water freezes, that movement slows right down and the bonds become fixed in a lattice structure, forming ice crystals. Water has now become a solid. The crystal shapes seen here are a result of the real angles you can get with our real atoms. These crystal shapes just get bigger and bigger in a fractal pattern, and that's why you get wonderful snowflakes. Each water molecule then acts like a mini magnet. There's a plus and a minus side. This attracts them together. In water, this is called cohesion. We can then write down the words hydrogen bonds on a small little arrow and apply them to our resource. Just to remind you as the teacher that hydrogen bonds are really important, but not forming any direct solid connection. Once this is finished, you'll never have to relearn this again. It becomes a look, see and read recall process where the displays become your memory and tells you what water is. So don't sweat it, it's worth building correctly for this reason. And finally onto gas. Some molecules can't form solids or liquids at this temperature, so the molecules remain really far apart with big gaps. The gas we went with is CO, or carbon monoxide. The alarms in your school looks for this gas as too much is bad for you. Instead though, humans need this one, O2, made with 2 oxygens. You can make any gas molecule you like. Make it your own, glue them down, add your label and just have fun. And congratulations, you now have a sturdy forever resource that will last you the test of time and can be shared between classes. We will be covering gases in more detail in our next episode, as well as solids in episode 8, so stay tuned. Water, as you know, kind of breaks the rules here, because it can exist in all 3 states on our planet, depending on temperature and pressure. So it really belongs in our video on solids, liquids and gases in its own right now. Hydrogen bonds is also how our DNA is joined down the middle. Yeah, our DNA is as strong as water. A little bit scary. Ice melts very fast and at lower temperatures compared to solids. But to melt rock, it would take well over 1000 degrees. But when water does get hot, it gives back its borrowed bonds to its neighbour and floats off into the air to become a gas. And as we can see from our display earlier, that leaves really big gaps in between each molecule. It's that simple. It's great fun getting the students to make water and arranging them into these simple little shapes to demonstrate the different states of a matter. For each student, all you need is a paper plate and some molecules. As always mentioned, just keep it simple and have fun. These lesson tutorials primarily focus on building the resource that integrates into your existing lesson plans and overlaps with other resource builds to help all science topics connect. So we can pause the video and have a read of our 4 basics. So next time we will be talking about sound and building an air composition mobile display, so don't miss it. So thank you for watching this video and we hope it helps you. I've been your host Paul Brereton, and remember, you're not just teaching STEM, you're telling a story, the true story of nature.